Now we need to start with a few definitions. So this is chapter 16, properties of curves, and section A, definitions. A tangent. What is a tangent? It is a straight line that touches a curve at a single point. Okay, and we've been talking about tangents all along. Okay, tangent to the curve, tangent to the curve, tangent to the curve. Okay, so if our curve is here, and we're talking about this point, then the tangent to that curve would look something like this. It only touches at that one point and no other points. Okay, secondly, normal. So this is a definition we haven't seen yet. A normal is a straight line that is perpendicular to the tangent. Remember, perpendicular means at right angles. Okay, so perpendicular to the tangent line of a point of contact on a curve. All right, so if we know the gradient of the tangent, if we know the gradient and we know the point of contact, we can determine the equation of the tangent line. Similarly, if we know the gradient of the tangent, therefore we also know the gradient of the normal. So let's put our thinking caps on for a moment. The gradient two lines that are perpendicular have what kind of slopes? Negative reciprocal gradients or slopes. Okay, negative reciprocal gradients. So therefore, if we know the gradient of the tangent, we also know the gradient of the normal, and we know the point of contact, so we can determine the equation of the normal. So looking at an example here, if I have a curve, and this curve is 2x squared subtract 5, and I randomly select a point on that curve where my x coordinate is 3. Of course, from prior knowledge, you know that you can substitute in to figure out what the corresponding y coordinate is. Which is 13. So we have this point of contact with ordered pair 313. We take the derivative of that. We know that it will be 4x using our derivative rules. And if we plug the x value in here of 3 from our point of contact, we get 12. This means that the gradient of the tangent line at that point at the point of contact, that particular point, is 12. All right, so we could determine the equation of this tangent line then. Okay, so we'd say whatever method you want to use. I'm most comfortable with y equals mx plus b. I know my gradient is 12. Fill in the point of contact. Negative 24. And the equation of our tangent line then is y equals 12x subtract 24. Okay, similarly, if we look at the normal to this point of contact and to this curve, the normal is perpendicular to the tangent. Okay, so we know that the slope here is negative 1 over 12. Equation of the normal. The slope is negative 1 over 12. The point of contact is still 313, and we can determine the equation of the normal. B is 12 3/4, or 48, 51 over 4. Therefore, the equation of the normal is y equals negative 1 over 12x plus 51 over 4.